Section 5.6, the quotient of two polynomials. So first, let us do a monomial divided by another monomial. So let's do on page 209, let's say problem number 2. In exercises 1 through 30, find the quotient. Okay, so let's do that. So I have 32 y to the 5th divided by 8 y cubed. So this is like what we've done previously. I'll just divide. 32 divided by 8 is 4. I have the same base y. Y to the 5th divided by y to the 3rd. Well, 5 is bigger than 3, so y will be in the numerator. 5 minus 3 is 2. So I have the base y and the power 2. And so if I simplify this, I just get 4y squared. So these first few problems are identical to what we've done previously. Let me do, let's say, problem number 6. Negative 6 x squared y cubed divided by 3x y squared. So let's simplify this first. Negative 6 squared is 36. X squared is just x squared. Y cubed over 3x y squared. 36 divided by 3, 12. X squared divided by x, x. Y cubed divided by y squared, y. And so I get 12xy. Okay. Now, let us do a polynomial divided by a monomial. So we're just going to divide each of the terms in the polynomial by that particular monomial. Let me do problem number 14. Fifteen x squared minus 10xy divided by 5x. So let me divide each of these terms, 15x squared and 10xy by 5x. 15 divided by 5 is 3. X squared divided by x is x. 10 divided by 5 is 2. Xy divided by x is just y. The x's cancel. And so you just get 3x minus 2y. Oh boy. Let me do problem number 18. 12 ab cubed minus 6 a cubed b over negative 3ab. So let's divide each of these terms by negative 3ab. So 12 AB cubed over negative 3AB minus 6 A cubed B over a negative 3 AB. And so positive divided by negative is negative. 12 divided by 3 is 4. The a's cancel. B cubed divided by b is just b squared. Negative divided by negative is positive. 6 divided by 3 is 2. A cubed divided by a is a squared. And the b's cancel. And so you get a negative 4b squared plus 2a squared. Let me do problem number 27. 15 y cubed z cubed plus 10 y to the 4 z to the 6 minus 20 yz over 25 yz squared. So let me divide each of these by the denominator, 25 yz squared. And so I get 15 y cubed z cubed over 25 yz squared plus 10 y to the 4th is z to the 6th over 25 yz squared minus 20 yz over 25 yz squared. Okay, so I can divide both 15 and 25 by 5, and so I get a 3 over 5. Y cubed divided by y is y squared. Z cubed divided by z squared is z. I can divide both 10 and 25 by 5, and so I get 2/5. Z to the 4th divided, y to the 4th divided by y is y to the 3rd. Z to the 6th divided by z to the 2nd is z to the 4. I can divide both 20 and 25 by 5, and so 20 divided by 5 is 4. 25 divided by 5 is 5. The y's cancel. Z squared divided by z is just z. Since the power of 2 is bigger than the power of 1, my z will be in the denominator. And, well, this is my answer. Let me put parentheses around these just to make sure that you see that the variables are not in the denominators. Let me do an example. Let's say negative 5 a to the 4x plus 9 a to the 3x plus 1 b to the y plus 1 plus 4 a to the 2x plus 1 over negative a to the 2x b. So let's divide each of these by the denominator. So negative 5a to the 4x over negative a to the 2xb plus 9a to the 3x plus 1 b to the y plus 1 over negative a to the 2x b plus 4a to the 2x plus 1 over negative a to the 2x b. So this is equal to negative divided by negative will be positive. I have a 5 in the numerator. I have the same base a. I have a to the 4x and the a to the 2x. Well, 4x is bigger than 2x with coefficients. And so, of course, it could be a smaller number of x's, like negative, but I don't care about that. I'm just looking at the coefficients. 4 is bigger than 2. And so so a will be in the numerator. Let me subtract exponents. 4x minus 2x is 2x. And well, I have a b remaining in the denominator. Positive divided by negative is negative. I have a 9. There's nothing to do with that guy. Next, a to the 3x plus 1 divided by a to the 2x. Well, 3x minus 2x is just 1x. I still have a 1. b to the y plus 1 divided by b. Well, I'll subtract 1 from the y plus 1 to get an exponent of y. Positive divided by negative is again negative. So I get a 4 here. A to the 2x plus 1 divided by a to the 2x. Well, 2x cancels, so I just get a to the first. Over, well, I still have a b in the denominator. And that is your answer. Okay, so let's recall the following. Long division. And well, I guess I'll also write this as the division algorithm. So suppose I had something like, oh, I don't know, 894 divided by 71. So let me try to divide this using long division. So this numerator here is called the dividend. This denominator is called the divisor. And let's divide. So 894 894 divided by 71. Okay, so let's divide. Well, 8 divided by 7 is 1, so let's put a 1 here. And 1 times 71 is 71. And let's subtract. So notice you're always subtracting. 89 minus 71 is 18. Let me bring down the next term. Okay. And so, well, 18 divided by 7, that's going to be 2. So let's multiply. 2 times 71, well, that's 142. And again, let's subtract. And so I get 42. Okay. So now you notice that 42 is smaller than 71. Since 42 is smaller than 71, that means that 42 is a remainder. Okay. So let's give you some names here. So this is my dividend. This is my divisor. This is my quotient. And now we've shown that this is my remainder. Since the remainder is smaller than the divisor. And so I can now write that 894 over 71 is equal to 12 plus 42 over 71. And so I have that the dividend over the divisor is the quotient plus the remainder over the divisor. And remember, the remainder is such that the remainder is smaller than the divisor. We could have written this in a mixed number notation, but since the mixed number notation doesn't work when you have variables, I won't write that out. So let me write this as a division algorithm form. So this just says that 894 is equal to 12 times 71 plus 42. And so this says that the dividend is equal to the quotient times the divisor plus the remainder. So that's your division algorithm. Well, it turns out that the division algorithm works not only for natural numbers, it also works for polynomials. And so let me write the division algorithm. For polynomials. Okay, so let p of x and d of x be polynomials. And suppose that my divisor is not 0. You don't want to divide by, so the division algorithm doesn't work when you're dividing by 0. So you can't have that, there exists a number such that 894 is equal to some number times 0 plus a remainder. because you couldn't do that. You'd get you couldn't get a remainder that's less than 894. Then there exist polynomials let me call them q of x, the quotient, and r of x, the remainder, such that, well, the dividend is equal to the quotient times the divisor plus the remainder. And well, the remainder in this case is smaller than the divisor. And well, the way we say that in this case is that the degree of the remainder is less than the degree of the divisor. And that's my division algorithm. So let's do some examples. Well, first off, let me do, say, problem number 34. X to the fifth plus x cubed minus 5x over x squared minus 2 is equal to x cubed plus 3x plus x over x squared minus 1, x squared minus 2. Okay, in exercises 31 through 34, identify the divisor. So I want to identify the divisor. In this case, the divisor is, well, what I'm dividing by, x squared minus 2. The dividend, what I'm dividing, x to the fifth plus x cubed minus 5x. The quotient, and so that's the result, which I get, x cubed plus 3x. So that's the result after dividing. And the remainder. And so my remainder is just x. And so this last term here is my remainder term. Okay. Let me do problem number 36. X cubed plus 5x minus 6 over x minus 4. In exercises 35 through 64, use long division to find the quotient and the remainder. Okay, so let's do something extremely analogous to what we did here in this particular example. Except now, instead of having a number, I'm going to have a polynomial. So let's divide. X cubed plus 5x minus 6 by x minus 4. First thing is to note that I don't have an x squared term here, so let me put a 0x squared as a placeholder for the missing x squared term. And now let's divide. Well, let's do x cubed divided by x. That'll give me x squared. So let's multiply x squared times my x minus 4. So I'll get x squared times x is x cubed. X squared times negative 4 is a negative 4x squared. And now let me subtract. Because again, when I was doing my division, I always subtracted. And so the x cubes cancel. 0x squared minus negative 4x squared is a positive 4x squared. Let me drop down the 5x. 4x squared divided by x is 4x. 4x times x is 4x squared. Negative 4 times 4x is negative 16x. And again, let's subtract. The 4x squares cancel. 5x minus a negative 16x, the same as 5x plus 16x, 21x. Let me drop down the negative 6. 21x divided by x is 21. And so 21 times x is 21x. 21 times negative 4 is a negative 84. And again, let me subtract. And so I get the 21x's cancel. Negative 6 minus a negative 84 is the same as 84 minus 6, 78. And so I get that x cubed plus 5x minus 6 over x minus 4 is equal to the quotient x squared plus 4x plus 21 plus the remainder 78 over the divisor x minus 4. And that is your answer. Note the following. And this is very important. Note that I could have written in the above 894 over 71. I could have written that in the mixed number notation, 12 and 42 over 71. But I would be wrong if I wrote x cubed plus 5x minus 6 over x minus 4 equaling x squared plus 4x plus 21, and then didn't put just like here, I didn't put the plus sign. If I didn't put the plus sign here, this would actually mean rather than here, if I don't write if I have a integer followed by a proper fraction, then it's assumed that the missing operator here is addition. However, if I have a variable, then if I have anything, any operator missing, the assumed operator is multiplication. So this would not mean I'm adding them. It would mean I'm multiplying, which is wrong. I'm not multiplying the 21 times 78. And so these are not the same. So notice that if you miss this operator here, then it's not a plus sign. It's multiplication. So this is wrong. So having that missing plus sign in the having a missing operator there does not indicate that there's a plus sign there. It indicates there's a multiplication there. So never, never use the mixed number notation when having variables. Let me do another example. Let me do problem number 42. Six x minus 12 x squared plus 8x cubed minus 1 over 2x minus 1. Well, before I do this division, let me write let me write the both the numerator and denominator, the dividend and the divisor, in descending order. So this will be an 8x cubed minus 12x squared plus 6x minus 1 over 2x minus 1. So if I write in descending order, then I'll do the long division. And so I have 8x cubed minus 12x squared plus 6x minus 1 over 2x minus 1. Okay, so let's divide. 8x cubed divided by 2x is 4x squared. Let's multiply the 4x squared times my divisor. 4x squared times 2x is 8x cubed. 4x squared times a negative 1 is a negative 4x squared. And now let's subtract. And so the 8x cubes cancel. Negative 12x squared minus a negative 4x squared is the same as 4x squared minus 12x squared, negative 8x squared. Let me bring down the 6x. Negative 8x squared divided by 2x is a negative 4x. Multiply negative 4x times 2x, I get a negative 8x squared. Negative 4x times negative 1 is a positive 4x. And now let's subtract. The negative 8x squareds cancel. 6x minus 4x is 2x. Bring down the negative 1. Well, 2x divided by 2x is 1 times 2x minus 1 is 2x minus 1. Subtract. Well, these cancel. And so you get that the original 6x minus 12x squared plus 8x cubed minus 1 over 2x minus 1 is equal to the quotient 4x squared minus 4x plus 1 with no remainder. And that is your answer. Okay. Let me do, no, I don't have any there. Let me do problem number 55. X to the fourth minus 1 over x squared plus 1. Well, I have some missing terms. And so what I'm going to do is I'm going to add in those missing terms. So I have here x to the fourth minus 1 over x squared plus 1. So I have no x cubed term, no x squared term, and no x term. I'll put those in. And here I have no x term. And so let's divide x to the fourth plus 0x cubed plus 0x squared plus 0x minus 1 divided by x squared plus 0x plus 1. X to the fourth divided by x squared is x squared. And so I get multiply, I get x to the fourth plus 0x cubed plus 1x squared. And now let me subtract. X to the fourth is cancel. 0x cubed minus 0x cubed is 0x cubed. 0x squared minus x squared is a negative x squared. Now, let me bring down the terms. Notice that in this case, I have 3 terms in the divisor. So let's bring down sufficient number of terms so that there are 3 terms in this that I'm going to divide. Negative x squared divided by x squared is a negative 1. And so I have negative x squared minus 0x minus 1. And so let me subtract. The negative x squared is canceled. 0x minus 0x is again 0. Negative 1 minus a negative 1. Well, those cancel. So you get 0. And so I get that x to the fourth minus 1 over x squared plus 1 is just equal to x squared minus 1. And that is your answer. Well, it's kind of confusing for students to do long division because they have problems with the sign and there's a lot of writing to do. So let me introduce something that's called synthetic division. And so suppose I want to do the following example. Let's divide 2x squared minus 9x plus 16 by x minus 6. That's a big number, but let's do that. And so we will do the following. I'll take just the coefficients of this polynomial in the dividend. So I have 2x squared minus 9x plus 16. So let's not write down any of the x's. Next, I have x minus 6. If I set that equal to 0, x minus 6 equaling 0, then that says that x is equal to 6. And so let me put over on the side here 6. Now let's do the following. I'm going to drop down the 2 and multiply this number 2 times this number 6. 2 times 6 is 12. And now let's add. 12 minus 9 is 3. Let's take this result, 3, multiply it by 6, 18, and let's add. 18 plus 16, 34. And now I'm done. So that was synthetic division. Let's write the result. So I have that 2x squared minus 9x plus 16 is, over x minus 6, is, well, notice I started with an x squared. I divided by x. So my result will be a polynomial of degree 1. So this is the coefficient for x, 2x. This is the other coefficient for 1, 3. And this is my remainder, 34 over x minus 6. And that is my result. So let's redo problem number 36. So we did problem 36. With long division. Let me redo problem 36. X cubed plus 5x plus 6 over x minus 4. So when we did this previously, it was convenient to put a 0 as a placeholder for the fact that there was no x squared term, but it really wasn't necessary. You could have done it without it. But since synthetic division is really only placeholders, you can't, not write the coefficient of x squared. So let's do this. I have 1x squared plus, 1x cubed plus no x squared plus 5x plus 6. I'm dividing by x minus 4, so x minus 4 equaling 0 means x is equal to 4. Put that over here. Drop down to 1 times 4 is 4 plus 0 is 4 times 4 is 16 plus 5 is 21 times 4 is 84 plus, plus 6 is 90. Uh-oh. And so my answer is x cubed plus 5x plus 6 over x minus 4 is equal to, I start with x cubed, so I'll have 1 degree less, x squared plus 4x plus 21 with a remainder of 90 over the divisor x minus 4. And that is your answer. Uh-oh, so let me just check. I think I did it. I think I had a sign error when I did this. Oh, I see. I put a minus. Ah, that's a plus 6. So I did it correctly, but for the wrong problem. And so that was a 90. So notice we get the same answer, and it's faster, obviously. So now we get the same answer since we have now the same problem. Um, okay. Let me do, let's say another one. Let's say, Suppose I do problem number 58. X to the 6 minus 1 over x minus 1. So again, setting x minus 1 to 0, I get x equals 1, so I'll put that on the side. Really what I can think of is that I'm changing the sign, and so instead of subtracting, I'm adding, that's what makes this synthetic division nice. So I have 1x to the 6th, no x to the 5th, no x to the 4, no x cubed, no x squared, no x minus 1. Drop down the 1, times 1 is 1, plus 0 is 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 1, times 1 is 1, minus 1 is 0. And so I started with x to the 6th. So my answer starts with x to the 5th. So I have 1x to the 5th, 1x to the 4, 1x cubed, 1x squared, 1x, plus 1 and no remainder. So that is your answer. Obviously much faster than synthetic division. Sorry. So the question is, well, what would happen if you had instead something that didn't have a 1 in front of the linear term, the linear coefficient being 1, in the divisor? And so what if you don't have a monic divisor, a monic linear divisor? Well, let's do problem, let's say 63. And so, problem 63, I have here 2x squared, 2y squared minus 5y plus 3 over 2y plus 4. So I can either divide every term here by 2 in both the numerator and denominator, or I can do synthetic division, then at the end divide by 2. And I guess I'll do that. I'll at the end divide by 2. And so I'll have here 2y squared minus 5y plus 3. I'm going to set 2y minus 4 to 0. Well, 2y plus 4 to 0. So I have 2y equals negative 4 divided by 2, so y equals negative 2. Drop down to 2 times negative 2 is a negative 4. Negative 5 minus 4 is a negative 9. Times negative 2 is a 18. Plus 3 is 21. And so now I didn't divide by 2 at the beginning, but I'm going to have to divide by 2 now. So now let's divide everything by 2. And so I get 2 divided by 2 is 1. Negative 9 divided by 2 is negative 9 halves. But let's not divide out that last term. And so I get that 2y squared minus 5y plus 3 over 2y plus 4 will equal, I have a quadratic divided, a polynomial degree 2 divided by polynomial degree 1. And so this will be a polynomial, the quotient will be a polynomial degree 1. So I have 1y minus 9 halves plus 21 over 2y plus 4. So the reason that I did not divide the last term by 2 is because if I did, then I would have to write my divisor as the simplified term where I divided by 2. And so to keep the same divisor, I didn't divide the remainder by 2. Let me do another one. Let's say that I want to do problem number 53. And I'm going to do this by synthetic division. So 27 a cubed plus 8 divided by 3a plus 2. And so I have 27 a cubed plus no a squared plus no a plus 8. And I'm going to divide this by 3a plus 2. And so 3a plus 2 equaling 0. 3a is equal to negative 2 divided by 3. A is equal to a negative 2/3. Drop down to 27 times negative 2/3. Well, 27 divided by 3 is 9 times negative 2 is negative 18. Plus 0 is negative 18. Negative times negative is positive. 18 divided by 3 is 6 times 2 is 12. Plus 0 is 12. 12 divided by positive times negative is negative. 12 divided by 3 is 4 times 2 is 8. Minus 8 is 0. Let's divide each of these by 3. And so I get 9 minus 2. Divide by 3. 9 minus 6, 4. And that's going to be 0. And so I get that 27 a cubed plus 8 over 3a plus 2 is equal to 9a squared minus 6a plus 4 with no remainder. And that is your answer. Let me do one more, I guess. Let's do this. Let me do an example. Find a number which, when divided by 2, yields the quotient 3. And so I want to find a number which, when divided by 2, yields the number 3. Well, if I multiply by 2, I get x is equal to 6. And obviously, well, 6 is a number which, when divided by 2, yields the number 3. Let me do, now seeing that as my guide, let me do problem number 66. Find the polynomial So notice all I really had to do is multiply 2 times 3, which when divided by x plus 1 yields the quotient x squared minus x plus 1. So I want some polynomial such that when divided by d yields the quotient. And so I want to find some polynomial equal to the product of the quotient times the divisor. And so I want x squared minus x plus 1 times x plus 1. So let me multiply this out. And so let me use the distributive property to simplify this. And so let's multiply by x squared negative x 1. And so I get x squared times x, x cubed, x squared times 1, x squared, minus x times x, minus x squared, minus x times 1, minus x, 1 times x, x, 1 times 1, 1. Well, the x squares cancel, the x's cancel, so I get x cubed plus 1. And that is the polynomial, which when divided by x plus 1 yields x squared minus x plus 1. Let me do another example. Find the number which, when divided by 3, yields 4 as the quotient and 1 as the remainder. Okay, so I want to find a number which, well, yields 4 as the quotient and 1 as the remainder when divided by 3. And so this is just 4 1/3, which is 4 times 3 is 12 plus 1 is 13 over 3. And so that number that I want is 13. So I found the 13 by taking 4 times 3 and adding 1 to it. Oh, which is just the division algorithm. And so this was just the quotient times the divisor plus the remainder. And that was the dividend. And so I found the dividend that way. And so let's do another example. let's say problem number 68. What polynomial when divided by x squared plus 3 yields the quotient 2x minus 1 and the divisor, the remainder, sorry, and the remainder 3x plus 4. And so I want to find the polynomial which, when divided by some divisor, yields a quotient with some remainder. And so I have the quotient is 2x minus 1. The divisor is x cubed plus 3. And the remainder is 3x plus 4. Okay, so let's do this. Let's multiply. And so I get 2x to the fourth plus 6x minus x cubed minus 3 plus 3x plus 4. And so this is equal to 2x to the 4 minus x cubed plus 6x plus 3x is plus 9x plus 4 minus 3 is plus 1. And that is your answer. Okay. So that finishes off section, whatever this was, 5.6.